Today's video is going to teach you everything you need to know about the inverse trigonometric functions, or inverse trig functions. Remember back in geometry we talked about these just a little bit. We have inverse sine of a ratio equal to theta. So these inverse trig functions are how we find angles instead of sides. So we've been using this way for quite a while. Now we're going to use the inverse to find angles. So let's try out this little triangle here we have at the bottom. Which trig ratio would you set up if this is the angle we are looking for? 23 is the opposite, 8 is the adjacent, and opposite and adjacent sounds like TOA or tangent theta is 23 over 8. So to solve for theta and figure out what that is, we want inverse tangent of the tangent theta. This is actually what's happening because whatever you do to one side you have to do to the other, but we don't often write it like this because inverse tangent and tangent end up canceling each other out, and we get inverse tangent of 23 over 8. Depending on what mode your calculator is in will give you two different values. If you are in radian mode, you should have gotten 1.236 radians. If your calculator is in degree mode, you would have 70.821 degrees. So in today's assignment on the worksheet, you're going to have to read very carefully whether you want your answer in degrees or in radians, and you will have to change the mode of your calculator accordingly. So degrees always has a degree sign. If there's no degree symbol, you can assume that your answer is in radians. Okay, let's look at a couple for you to practice. Use your calculator in radians to find the inverse sine of 0.65. So type that in quick, and you should get 0.708 if we round to 3 decimal places. Okay, the next one here says in degrees. So go into mode and now change your calculator into degree mode and type in inverse cosine of negative 0.12. You should, if your calculator is doing what it needs to do, 96.892. And that is degrees, so we write the degree symbol. On the right here, we have some really useful information about what our calculator is actually going to tell us. Anytime we use inverse sine or inverse tangent down here, our calculator is going to give us a value somewhere in either quadrant 1 or quadrant 4. Same with inverse tangent. Those two things give us values in quadrant 1 or quadrant 4 every single time. Cosine is a little bit of an oddball, and it gives us values, the inverse cosine, of 1 in quadrant 1 or in quadrant 2. So always something to keep in mind where our quadrants or where our trig functions are giving us our values and where we actually want them to be. And here's an example of kind of what I'm talking about with that. Okay, we have a given equation here, cosine theta is equal to negative 0.345, and we're looking for theta somewhere between 0 and 2 pi. Because this is 2 pi, we're looking for a radian answer. So your calculator should be in radian mode. Now, what two quadrants for cosine give me a negative value? If you think over to your SATC thing we've been talking about, which two quadrants are our answers going to be in? Cosine is negative in quadrant 2 and quadrant 3. So when we type in inverse cosine of negative 0.345, your calculator is going to give you your first answer as 1.923 radians. That is an angle right here. Theta is 1.923. That's our quadrant 2 answer. We need to also find the one that is in quadrant 3. We need to find this one. To do that, we find reference angles. So from this very first answer, we're going to find a reference angle right in there. And subtracting from pi is what we have to do to find that reference angle. So if you take pi minus 1.923, you get a reference angle of 1.219. Now to move our angle into quadrant 3, our second answer, it's the same reference angle of 1.219. So this reference angle has to be 1.219. So our whole angle there is going to be pi, to get all the way to pi, and then another 1.219. So pi plus 219. And our second answer will be 4.360. So we have our two answers, one in quadrant 2 and one in quadrant 3. Our next example deals with degrees. So now we need to be in degree mode. And we're looking only in between 90 and 180. So 90 and 180 is this quadrant up here in quadrant 2. Okay. Another peculiar thing is that we have cotangent equals -3/2, and there isn't an inverse cotangent button. So I would suggest we talk about this instead as -2/3 being the tangent ratio, because they're reciprocals of each other. So now tangent, or theta, is going to be inverse tangent of -2/3. And when you type that in, you are going to get -33.690 degrees. That angle is definitely not between 90 and 180. So remember that our calculator gives us tangent in either quadrant 1 if it's positive or 4 if it's negative. So this is telling me I have a reference angle right here of 33.690. Okay, that's not my final answer. What I want is the angle over here that has the same reference angle. So if, remember, vertical angles are equal, if that reference angle is 33.690 up there, I want the angle to get there. So I'm going to take 180 and subtract the reference angle of 33.690 and get the answer I want in quadrant 2 of 146.310 degrees. How'd that go for you? Great. Very similar. Now we have two things that say without a calculator. That usually means that they're going to be unit circle types of questions, those special triangles. Okay, so when we think about our special triangles, if you're getting a root 2, you should be thinking this is a 45, 45, 90 triangle, right? Hopefully all of you are familiar with root 2 only happening in the 45, 45, 90 triangle. So I think about this like sine has to be positive in quadrant 1 and in quadrant 2, because again we're talking about that SATC thing. Who's positive where? Okay, and if it's 45, 45, 90, that means I have a 45 degree angle there and a 45 degree angle there. So one of my answers here, theta, will be 45 degrees, and I was allowed to use degrees because of the 360 there. And then I need my second one is this angle here with a 45 degree reference angle. So that second one will be 180 minus 45. Second one is 135 degrees. So there's the two answers that I want for that answer. Next one, tangent. Check this out, we're in radians. What two quadrants is tangent? Positive, always the first. And then SATC, also third. Okay? If tangent is equal to 1, that means your y over x has to equal 1, and y and x both have to be the same thing. Again, with your special triangles, the only triangle that has two sides the same length is a 45, 45, 90 triangle. So we have our 45-degree angle here, and we also have another 45-degree angle down here. We were in radians, so we want to think of our 45 degrees as pi over 4, and then that's our first quadrant. Then I need to get the one that brings me all the way over into quadrant 3. So this is pi plus another pi over 4 would give me 5 pi over 4. So our two answers are pi over 4 and 5 pi over 4. Let's do one quick application problem. We have a slide, and we want to figure out the angle of elevation. So I have a hypotenuse of 14, and I have a height of 9, and I want to figure out theta value over here. Set up a trig ratio right now and see if you can find that, and then let's compare answers. I think this looks like a sine ratio, so I'm going to use the sine of theta is equal to 9 over 14, and 9 over 14, or the inverse sine of 9 over 14, should give me a value of a theta value of 40.005 degrees, or right around 40 degrees. Did you get that too? That's great. I hope this helps you on your worksheet. If you have any questions, ask your teacher. Have a great day.